Hi, I'm Armando Fox from UC Berkeley, and I'm pleased to be virtually telling you about the work that David Patterson and I have done on scaling practical software engineering education for the 21st century. Not too long ago, when Dave Patterson and I recently offered our software engineering course, it happened to coincide with the rollout of the Obamacare website in the United States, which in some cases made news even outside of the US itself because of the number of problems the rollout had. The system's uptime was terrible, and those of you who know something about operations know that we often measure uptime of a website in terms of the number of nines of availability. So for example, 99.9% availability would be 3 nines, and that's a typical target that good internet sites try to achieve. 95.1% was the best that the Obamacare website was able to do, and that was after several weeks of extreme reconditioning because the site had started out with only 42.9% availability. So we can think of that as 1/4 of availability rather than 3 nines of availability. And that doesn't even include scheduled maintenance. So what happened? Why is the country that was able to produce great websites like Amazon.com and Facebook that sustain enormously high traffic and are quite reliable unable to do this? Could it have something to do with the way we're training some of our students? Because David Patterson and I had been thinking about the fact that Berkeley's software engineering course at the time actually had a mixed reputation among the students. It was really seen more as a programming project course. And as we asked colleagues at other universities, we found that they were often facing similar problems. We narrowed it down to a few different reasons. First of all, the amount of time you have with a student over a typical semester is actually quite limited. At Berkeley, a semester is about 14 weeks. A typical course is expecting the student to put in 12 hours a week of effort. So that's the equivalent of about 3 weeks of full-time work over the course of the semester. That's the amount of time we have to impart the basic principles of software engineering as opposed to simply programming. Most instructors aren't necessarily experts. At Berkeley, we looked over the last 20 years and found that 16 different faculty have been assigned to teach the software engineering course in that time, and we surely have not had 16 software engineering faculty specialists in the last 20 years. There's many ways you can teach the course. There are traditional plan and document methodologies like waterfall and RUP, and more recently there are agile families of methodologies. So which one would you teach? And in particular, if the professor teaching the course is not a practicing software engineer, how much credibility might they bring to recommending one methodology over another? And finally, we looked at some of the most popular textbooks used in software engineering courses, and we found that even though software creation is really the ultimate learn-by-doing craft, the textbooks that we looked at were really more like surveys of existing techniques rather than being packed with learn-by-doing examples. So we agree with the famous Chinese philosopher Confucius, I hear and I forget, I see and I remember, I do and I understand. We believe that students need to learn by doing, and that a combination of teaching software engineering skills and techniques would have to be combined with a programming project. Otherwise, students would come out of the course programming the same way they always had, rather than having learned anything about how to structure, design, and develop well-behaved software. So the result of this, predictably, is that many students are actually poorly prepared for a career in software, even though it's such a great career path. One common outcome from courses like the ones that I've described are that students essentially ignore what we teach them. We try to teach them about design patterns and good testing habits, and they pretty much just build a project, demonstrate it, and keep building software the way they always have. A second common case is students are taught methodologies that actually don't work for very large projects, which led us to some thinking about how we ought to teach the course at Berkeley. But the combination of these factors makes it a hot potato course that nobody wants to teach. Instructors often get poor ratings from the students from teaching it, and the students don't feel like it's relevant or preparing them for their careers. And we've certainly had employers tell us that, especially in courses that focus on traditional waterfall methodologies, they're falling more and more out of step with how software is actually built at some of those companies. So let me talk a little about how we reinvented the software engineering course at Berkeley, I believe with some success. I'll tell you about how we have evaluated the revamped course, and most exciting, how we believe we're now in a position to help others replicate our success through the combination of massive open online course technology and a good inexpensive book. So when we set out to revamp the Berkeley course, we actually asked for advice from some of the leading software companies such as Google and Microsoft and Amazon Web Services, Twitter, Facebook, and so on, who hire a lot of our students. Unanimously, the companies we asked said that students are good at writing code, but they lack other equally important skills to make them software engineers effective in a 21st century environment. Unanimously, they all agree that the number one skill that was missing is students don't know how to handle legacy code, which is pretty important because for most students, their first job will not involve writing greenfield code. They also said that students really need better practice at working in small teams, in particular when those teams have to work with a non-technical customer to translate the customer's business need into something that's buildable. And finally, that students don't really understand how to do automated testing. They haven't been instilled with a culture of testing being part of the development lifecycle. So we took these as challenges for reinventing our course. In deciding how we were going to teach the course, we had at the time employed a part-time programmer from industry to help out with programming in one of our research labs. He was a practitioner of Agile, and it occurred to us that this might be the right time if we were going to reinvent the course to really change the focus to Agile. The Agile Manifesto from 2001 essentially said that we're building effective software by valuing individuals and interactions over processes and tools, by valuing working software and prototypes over comprehensive documentation, by valuing collaboration with the customer over negotiating a contract and pointing fingers when things don't go as expected, and by valuing how we respond to change rather than making sure that we can plan in advance for every possible contingency. Which is to say that it's not that the things on the right are not valued, it's just that the things on the left are valued more. And for many years it seemed like it wasn't obviously respectable to teach this in academia, but it's become respectable quite recently, and in part, it's because study after study has shown that it works quite well. A study from 2013 that surveyed tens of thousands of software projects found that looking at small projects of budgets under approximately $1 million that were done using Agile methodologies, 76% of them were delivered on time and within budget, 20% of them were either over budget or delivered late, and only 4% were entirely abandoned or scrapped. Whereas, in contrast, large projects with budgets over US $10 million and which were typically conducted using non-Agile methodologies, only 10% were delivered on time and within budget. Over half were delivered over budget or beyond schedule, and an incredible 38% were simply abandoned. The project effort had been entirely wasted. And the same study found that across various companies, even large established software companies that have existed for decades, 55 to 80% of teams were using some form or some elements of the Agile methodology. So Agile has definitely become mainstream by now. Now, of course, a standard objection might be, even if it works well for small projects, what would you do if you had to build a large system? Well, we can take inspiration from a successful large system like Amazon.com, which really is not a single system, but a collection of dozens of microservices. In a service-oriented architecture, there are individual systems that are only allowed to communicate via externalizable network APIs. And Jeff Bezos, very early on in the company's history, about 6 or 7 years after the company was founded, issued a company-wide mandate that the entire code base needed to be restructured around service-oriented architecture, which some of us think he was quite far ahead of his time. The individual services expose simple APIs. That means that the individual services can be scaled independently because they're being built and developed and operated all by the same team. Jeff Bezos is given credit for coining the term two-pizza team, meaning that a team shouldn't be larger than the number of people that 2 pizzas could feed. And by having these recombinable services, you could decide that if you didn't want to deploy Amazon.com, you could build a different service, like a book recommendation service. Now, by now this has received wisdom, but Amazon has since been able to sell the infrastructure that supports their own services as AWS, or Amazon Web Services, which many of us use. So, if we're going to teach students software engineering using Agile methods, what are we going to have them build? Because we've certainly found as instructors that students are more motivated if they can produce a project that they themselves find compelling. And I would say in the early part of the 21st century, the clear targets are mobile applications and cloud-based or web applications. So which one of these are we going to choose? One question we asked ourselves is there one that fits better with the Agile lifecycle? And in fact, we decided that the web applications that use cloud computing, because they make it easy to do continuous deployment rather than, for example, having to push applications out to customer devices every time they're updated, would actually be a better fit for the continuous change and continuous incremental improvement model that is so core to many of the Agile methodologies. So we decided we would go with software as a service. Were we going to recommend a specific set of tools or allow students to choose whichever one they wanted? This was another controversial decision, but ultimately we decided if it's important for students to learn by doing, we need to give them the best tools possible in order that they can try the advice that we're giving them on techniques they should use. And our survey with our own students revealed that the Rails ecosystem and the Ruby language today have absolutely the best tools for testing, for code grooming, and really for supporting various aspects of the Agile lifecycle. And the idea that students could immediately start using these tools and learning by doing was the factor that convinced us that was the way to go. And I'll give some examples of that in the next part of the talk. So, in summary, how did we end up revamping the course? Students would do projects that were deployed as software as a service, working in small teams. We would use some version of Agile or extreme programming in which the students did multiple iterations, continuously refining the project, usually working with an external customer. They would use the world-class tools that have come out of the Ruby and Rails ecosystem, virtually all of which are open source, some are even hosted as a service. And we decided that we would try to recruit non-technical customers from both inside and outside the campus to give students the experience of having to work with a customer who thought in terms of their business needs and not in terms of software engineering. We were able to find campus organizations that already reached out to nonprofit organizations, campus units, and NGOs, and typically these organizations are happy to have the help of students because they wouldn't necessarily be able to afford to hire programmers themselves. And because they're non-technical customers, the students would have to learn to communicate with them. And we would focus on service-oriented architecture so that if a particular project was too large to be tackled by a small team, we would help the students divide it into smaller services and have each team work on services with APIs that they agreed upon. So that's roughly how we revamped the course, and I'd like to tell you specifically about the learn by doing philosophy, how it applies to the course, and why we think that the results we've gotten so far vindicate our choice of Rails as the ecosystem for teaching the students some basic software engineering skills in the context of the Agile lifecycle. The basis of the course really is an Agile or XP iteration, and we use 2-week iterations for reasons I'll mention in a moment. Each iteration begins with the student team having a meeting with their customer, which can be face-to-face or virtual over the internet, and deciding on which features or stories they're going to work on during that iteration, for which the students will then produce lo-fi pencil and paper mock-ups, which they will go over with the customer. The next step is to turn those mock-ups into user stories, which are basically stylized narratives describing when the users interact with the application in a particular way, what behavior they would expect to see. Now comes the next step in which the students will learn by doing by converting those user stories first into integration tests using a remarkable tool called Cucumber, which essentially lets us write user stories in stylized plain text and have those stories be executable integration tests. In other words, it provides a direct bridge from the non-technical communication that they did with the customer to the set of integration and acceptance tests that will ultimately help evaluate how much they were able to do during the iteration. They then architect and implement the stories using test-driven development, using unit tests and functional tests to cover their code, and as they go, they're measuring both code quality. We use a tool called Code Climate for that, and they're measuring code coverage with the RSpec tool, which is descended from the JUnit class of unit testing libraries. They will measure their velocity, which is an estimate of the amount of work done by the team by assigning each user story a certain number of points based on its estimated complexity, and because the stories tend to be simple, the margin of error in estimating the velocity tends to be low, and it's one of the skills that we would like the students to develop. Finally, every iteration ends with them deploying to the public cloud. We use Heroku, which is a very easy-to-use platform as a service, but the important thing is that the app is publicly deployed where the customer can interact with it directly and get a sense of the extent to which what the customer asked for and was agreed on earlier in the iteration has actually been deployed to production. That's one iteration, and in our course, they're repeated typically 4 times. Interestingly, we found that most of the techniques that we teach, including behavior-driven design and test-driven development, when we asked the students, how many iterations did it take you to really appreciate the value of using these techniques, the answer was, in almost all cases, more than 2 iterations. So we believe leaving room for more than 2 iterations in the project is actually fundamental. Of course, this being a software engineering course, we do discuss important standard topics such as how to deal with legacy code. In fact, we have an entire programming assignment showing how to apply the same Agile techniques that are used for greenfield development to the exploration of a legacy code base. And of course, we talk about design patterns, the solid guidelines for class architecture, refactoring at both the class and method level. And the timing of the course is such that by the time the students are getting into the more complicated phases of their project, there really are opportunities to apply refactoring and design patterns which might not have existed when the project is too simple because it's just getting off the ground. I mentioned that a key philosophy is that students ought to learn by doing, and for us what that meant was, instead of only presenting methodologies, we would always present an accompanying tool that would allow the student to put that methodology immediately in practice. Of course, a fundamental aspect of introductory software engineering is understanding software architecture and the role of design patterns. We chose Ruby and Rails because, as we said, both the framework itself and the tools that have arisen around it are excellent for illustrating concepts of software architecture. Plus, we can introduce basic concepts of how software architecture fits with internet applications. For example, the model view controller structural pattern. For test-first development, we have the students use RSpec, which is a descendant of the JUnit family of tools. I mentioned Cucumber, which I'll give a very short illustration of how it works, which is the bridge that allows user stories to become integration tests. For tracking the user stories, estimating progress, and keeping track of which team member has delivered what, we use Pivotal Tracker, which is a hosted service that is available for free for open source projects. Of course, all of the students' code is managed using Git, and we show them how to use features on GitHub such as pull requests to gracefully coordinate the working of several people on a team. And as I mentioned, for deployment, we use cloud computing. In particular, we teach the students about horizontal scaling, how the three-tier architecture works, and how it maps into commercial platform as a service offerings such as Heroku, which is the one that we use. So let me give an example specifically of learning by doing by showing how Cucumber helps the students turn non-technical user stories into integration tests. I'll use an example from a recent offering of the course in which the students' team were developing an application to help automate the scheduling of visiting PhD students to UC Berkeley. Typically, all of the incoming students come to visit on the same day, and they're trying to make appointments with professors in order to discuss their academic goals, and previously the scheduling of those appointments was handled manually. Having automated part of the process, here's an example user story that came from the actual staff member in the computer science department who had done this scheduling manually. As an EECS staff member, that's the stakeholder, so that I can accommodate last-minute faculty requests, that's the goal that they want to achieve, I want to manually be able to change or tweak a faculty member's schedule. So there's a stakeholder, there's a task they want to accomplish, and there's an ultimate goal that that task is supposed to achieve. The students are mocking up the application with their customer, drawing pencil and paper diagrams and storyboards to show how this behavior might work if it were implemented. For example, they might start from a master view of the calendar such that clicking on a faculty member's name would take them to the appointments scheduled for that faculty member. And if they modify some of those appointments and then save changes, they would return back to the master calendar and expect to see those changes reflected there. That lo-fi mockup can easily be converted into a set of stylized steps. This is the format of a Cucumber input file, and you can see that it has a description of the feature, which is essentially a comment, and then it has a series of steps in a scenario that describe, step by step, how the feature would work. The steps with the label given establish preconditions. Given Valve Alcohol is available at 1020. When steps establish an interaction that the user would have with the application. So given that the preconditions hold, what will the user attempt to do to the application? How will they stimulate it? Then steps indicate what should happen as a result. In other words, they encode post conditions. And you can see that it's written in somewhat stilted, stylized prose, but the reason is that every one of these steps is going to be linked to a block of code that sets up a precondition, stimulates the application by simulating a browser, or checks a post condition by examining the app's internal state. The important aspect for us is that this representation is the one that the user and the development team can agree on, written in plain English. The idea that methodologies are supported by tools has given us a lot of advantages. For one thing, it's easier for students to follow our advice about a methodology, such as it's easier for students to follow our advice regarding methodologies, such as how to communicate with the customer and turn their non-technical description into something like an acceptance test, if there's a tool that directly supports that goal. It also gives the instructors insight into how the students are working, so we can more easily grade their work and evaluate the extent to which they're following the process. They can also quantify their progress each iteration because they can keep track of stories at a fairly fine-grained level, and they can get quick feedback on their estimates. From iteration to iteration, we like to see the students improve their ability to estimate how many stories they will be able to complete. And all of these tools are free. Some are hosted in the cloud, so there's no financial barrier for us to recommend that the students use them. Now, obviously, one question we'd have is whether students going into industry would retain any of the methodologies that we had taught them or not. So we took surveys of our students 2 years out after they had gone through an early version of the revamped course. And we asked them, first of all, what practices, languages, techniques, and so forth they were using in their industrial jobs. One thing to notice is that only 19% of the respondents were using Ruby or Rails. So the fact that we had taught the course in that language wasn't necessarily particularly valuable, which is okay, because our goal was not necessarily to instill the love of a particular framework. It was to see whether the tools of that framework could be used to impart fundamental knowledge about testing, about working with the customer, and other aspects of software engineering. So we also asked them, of the techniques that we taught you, which ones were useful to the extent that you find them helpful in the day-to-day functioning of your career? And we were pleasantly surprised that 75 to 80% of students thought that the experience that they had got with design patterns, with unit testing, and so on, was actually extremely useful. These are some of the elements that in our older software engineering course typically were dismissed by the students as not being particularly relevant to the real world. So we have some informal evidence that at least students are able to achieve the goal of mastering the techniques and then transferring them to other tools, languages, and frameworks, which is an encouraging result for us. The employers also agree. We have a fair amount of feedback because we have a lot of dialogue with the employers who employ our students, and we've gotten very good praise from well-known companies. The customers with whom our students work, the nonprofit groups and the NGOs, are routinely extremely pleased with the students' work, and more than half of them are using some version of the student-developed application, even though it was only delivered as a prototype. In fact, if you'll allow the luxury of this 1-minute video, I'll let the customers speak for themselves.
That was the beauty of it. They contacted us and arranged to meet with us every week. Sometimes we met weekly, sometimes it was every 2 weeks, but never for more than 20 minutes probably.
Yes.
Didn't take a lot of time for us, but trying to convey to them the rules that we have to go by for vacation. We showed them what we did, and then we showed them the rules and gave them a copy of the rules. It was so smooth.
Yes, they came back with ideas that we couldn't have put forward and brought into this institution.
Sounds like you got a lot of opportunities to give feedback on what they were doing, and that they tried to incorporate your suggestions.
And they easily fixed any
They
concerns.
did. It was amazing.
So now with this prototype in place, is there a plan to use this and hope things get better?
Correct, yes.
So our vacations are due February 1st of each year, and so we start usually in January, and we're going to start using it.
I think Laura and I, we're both on the 5th floor. We'll end up trialing this this year, and if it's successful for us, it'll probably spread through other units in the hospital.
Well, that's great.
Yeah.
Thank you very much for your time and also for working with our students.
Thank
It was
you.
great.
It was a pleasure.
Now, of course, it's great to have happy customers, but if you're teaching an academic course, it's also important that our colleagues in academia agree that what we're teaching is actually valuable. ACM and the IEEE Computer Society recently revised their recommendations for teaching software engineering, and the pre-publication draft included some language around the importance of utilizing project teams, and in particular, the importance of learning to do project work through an iterative approach. And that's supported by our own experience, that students report that it takes a couple of project iterations for them to really understand the value of some of the techniques that, for many of them, are quite new, such as test-driven development. However, one question we had when evaluating our course relative to the new curriculum guidelines is the extent to which those guidelines embraced or approved the use of Agile techniques in academia. What we found in looking over the 2013 draft is that there were a lot of topics that were in the draft software engineering recommendations that could readily be mapped to their Agile equivalents. So while there were very few mentions of Agile itself, we found that, for example, user stories are essentially a lightweight form of eliciting requirements. The idea that Stories and mock-ups are combined with customer meetings, and the notes and interviews regarding from those along with the stories form a kind of project documentation. And the scenarios that are used in Cucumber essentially become the integration test of record that tests each of those stories. We also go into detail in both the course and the accompanying book, which I'll tell you about later, in comparing the way certain things are done in Agile environments with the way they're done in top-down plan and document environments. Some of the plan and document processes can be covered as part of project management. We've done substantial revisions of our textbook so that whenever we present the Agile version of a particular practice, we also contrast it with the plan and document version of that same practice and try to give some advice on what sorts of projects would be appropriate for each methodology to use. So the textbook includes a plan and document perspective, even though we do focus on Agile. And for those of you who are familiar with the curriculum standard, there's a number of categories such as Core Tier 1, Core Tier 2, and so forth. We have an instructor's manual that shows how the material in the course and the book can be used to create a syllabus that covers 100% of the Core Tier 1 IEEE ACM learning objectives and 94% of the Core Tier 2 learning outcomes. Having done this successfully at Berkeley, we're actually very excited now that we have an opportunity to make it much easier for other instructors to adopt part or all of what we've done. And that's what I'd like to talk about in the final portion of the talk. So I'm going to talk about curricular technology transfer and in particular the role that massive open online courses, or MOOCs, have played in our experience, as well as the more recent role of SPOCs, a term that we coined for a small private online course, which is what you get when you take MOOC technology and mix it back into your own private classroom. At the time that Dave Patterson and I started developing our textbooks, in November 2011, this was just before Coursera was founded, and massive open online courses were very much in the news. We were invited by our colleagues Andrew Ng and Daphne Kohler at Stanford, where they had been experimentally putting some of their courses into what is now the ubiquitous MOOC format. They asked if we would be interested in adapting our course as well. One of the reasons that we said yes is that the Berkeley course, after having reinvented it, was proving to be extremely popular with the students. I'll show you some enrollment numbers shortly, but originally this was a modest-sized design-centric course with maybe 50 to 60 students, and we were getting much more demand than we could handle. So we had already started thinking about whether we could scale the campus course, for example, by developing detailed automatic graders. In fact, one of the insights we had early on was that the same high-quality tools that the students were being asked to use to develop integration tests, user stories, test coverage, and so forth, could possibly be repurposed to automatically evaluate their assignments. I'll tell you more about the autograders in a moment, but to make a long story short, we've re-recorded all of the material in the MOOC about 3 times since the original offering, as we've continued to improve the material at Berkeley and alongside the material in the textbook. We've had 6 total offerings of the MOOC to date, and I have to give a tremendous amount of credit to Professor Sam Joseph of Hawaii Pacific University. He was one of the students in the very first cohort when we ran the MOOC, and he became so attracted to the way we were teaching the material that he has become our course facilitator and is also facilitating the SPOCs that other instructors use, more about which in a moment. But back to the theme of autograding. We developed, with the help of our TAs really, who did most of the work, several different autograding strategies, and the idea was that we wanted to be able to give students feedback not on just short multiple choice questions, but complete programming assignments. We wanted to be able to test not only the correctness of their code, but also investigate whether, in examples where we were, for example, asking them to use a particular idiom, inspect whether their code was actually using those idioms, such as some of the functional collection idioms that Ruby has. We wanted to be able to keep track of code quality and make that part of the grade, along with test coverage. So we've got really 4 different auto-grading strategies, 3 of which have to do with grading complete programs. In the first strategy, the students really submit code, and there's some repurposing of the RSpec grading tool that allows that code to be graded usually in a matter of a minute or less. All the autograders are cloud-based, and I'll show a citation for a paper where you can go read about them. We also have an assignment in which we ask students to write integration test cases. And in order to check that assignment, we actually use a simplified form of mutation testing in which we have a reference application into which we insert bugs selectively, checking that there are student tests that fail as each of those bugs is inserted. And we have an assignment, as I mentioned, in which students have to enhance and deploy a legacy code base As well, we have several projects in which students develop small applications as part of a scaffolded programming assignment and deploy them to the public cloud. In those cases, we're able to use the same tools, RSpec and Cucumber, in a different mode that would be used for testing a staging deployment in an industrial environment. So in fact, not only are the students using world-class tools, we've repurposed those same tools in the service of autograders. These have been running in the cloud since 2012, and they have now, I would say, graded millions of programming assignments to good success. And they're one of the key elements of the class because students get instantaneous feedback on what they're doing, and in fact, we allow them to resubmit multiple times to improve their score, which is something that we could never do if we were relying on human teaching assistants to grade each and every assignment. In fact, we're working on an extension of the autograders now that's actually fairly exciting from my point of view because it takes advantage of the scale at which students can enroll in these large online courses. In particular, we'd like to give students some feedback on how to improve their programming style. I'm showing 3 examples of actual student submissions to a very simple finger exercises kind of warm-up programming assignment. And all 3 solutions solve the same problem, which is to create buckets of anagrams out of a list of words. But you can see that the solution on the far right is just 4 lines of code. It's about the most elegant that it's possible to get in Ruby. What we'd like to do is give hints to the students who have the assignment on the left and in the center so that their code can ultimately become as concise as the code shown by the student on the right, who clearly has mastered the idioms of the language. And to do this, we essentially create a DAG of all the assignments in which 2 submissions are connected if there's lower than a threshold difference between the weighted abstract syntax trees of those submissions. In other words, they're structurally not very different. And if there's a lower bound on the improvement in code quality going from one submission to the next. We use various tools to measure code quality. For this simple example, we used a tool called, that measures a Ruby-weighted variant of cyclomatic complexity, but different metrics could be used. And essentially what we can do is we can look for a particular student's submission, find a path from that submission through other submissions to one that is representative of the best that you can do stylistically, and then we can actually show the student a series of code changes that might allow them to incrementally refine the quality of their code. So not only have they passed the unit test, but we're trying to give them feedback on their code style as well. And this is work in progress. But the reason that we're excited about it is that one of the early criticisms of MOOCs is whether they would be able to be a rich experience given the scale of the course, the number of students enrolled. And we think this is an example of adding richness because of scale rather than worrying about richness despite scale. Now, the very first time that we ran the MOOC, and in fact, each time that we've re-recorded the MOOC based on our live classroom activities, one of the things we realized we needed very early on was a separate copy of the course that would be off limits to everyone except the Berkeley students. For one thing, we wanted to be able to try out new programming assignments that had not yet been debugged and possibly weren't ready for prime time. We also had some additional materials, different exams, and so on, that we only wanted to have visible to the Berkeley students. So Coursera and later edX helped us with this by essentially creating a separate copy of the course. And we ultimately coined the term Spock to describe this idea. It's the same technology running on the same learning management system that the students see. And in fact, the autograders that I just described, which are running as a service on AWS, are serving both the very large MOOC population and the much smaller population in the Spock. This has turned out to be such a powerful idea that edX is now adding features to their platform specifically to support it. But from the instructor's view, and the reason that we're excited about it, what it means is that it's essentially autograding as a service. The instructor, any instructor really, can have a complete copy of our course, but they can decide what to do with the various materials, which ones to use, which ones to leave out. They can even, in some cases, integrate their own materials, and the back end of all of the autograding is handled for them with zero installation. Now, we proposed this idea in 2012, and an immediate criticism we got is that we're going to be turning professors essentially into glorified teaching assistants who will sort of parrot the MOOC-based courses. And the automatically graded assignments are clearly useful to everybody, but are we really expecting that other instructors are going to use our videos, if they're going to prepare their own lectures, or if they're just going to point students at our content? Are they really just going to be adding no originality and no voice of their own to the existing course? So we actually did a pilot experiment early on to see if this was going to be a risk. And what we found was that the reality was that Spocks can actually be a huge boon to the faculty, and we wrote a Communications of the ACM article called From MOOCs to Spocks that discusses this theme and has actually improved their morale. In our initial pilot experiment, we worked with just 5 faculty, 4 of them in the US and 1 in China, and you can see that there's a few of the elements that we provided that all of them made use of. For example, they all used the textbook, they all watched our videos on their own, and they certainly all used our autograders, which they found allowed them to focus more of their effort on individual students and on additional work rather than on the grunge work of grading assignments. But you can also see that beyond that point there was quite a bit of variation. Some of them flipped their classroom, had the students watch our videos, and did other activities in the classroom. Others decided to use our videos as a basis for creating their own lectures, either live or recorded. Some of them used the online course materials that we provided in the Spock. Others used only the materials that allowed the submission of homeworks to the autograders as a service and otherwise ran the course as a traditional course. So clearly, from this group, it didn't seem to be the case that everyone was parroting the same course material that Dave and I had created. They were actually using it in quite different ways to meet the needs of their own students, which is what got us excited about the idea of the Spock as a mechanism for technology transfer. So what we found overall, if we had to draw one lesson from this, is that the leverage of the instructor is improved if we can automate away some of the tasks that would normally be done by rote. In fact, in the Berkeley course, we found that because all of the grading of the assignments has been automated, not only the instructors, but the teaching assistants can focus almost exclusively on grading the student projects, which is where the real software engineering learning is going to occur. The book is accompanied by a lot of different materials available for instructors. We have both our PowerPoint slide decks as well as videos of us presenting the material to students at Berkeley, all organized by chapter and section of the book. We have the automatically graded programming assignments, which, if you don't use the Spock, can certainly be graded in the traditional manner with the reference solutions that we provide. We have a number of activity worksheets for either small group work or pair programming work. And we have banks of questions suitable for both quizzes, where we have some short answer or multiple choice questions, as well as for exams, where we have some more open-ended questions. But we think the more interesting way to package the course really is in the Spock, which is a 100% hosted experience on edX, the open source learning management system. And you can see that the Spock actually brings together all of these resources in quite a nice way. Everything is organized by week of the course, so the topics are broken down into subtopics. Our lecture videos, should you choose to use them, are available, and they even have subtitles in English. If you use our lecture slides, which can be downloaded through the Spock, the slides even include self-check questions that you can use in the classroom, as well as using them as part of the online experience. We usually just have students use clickers or hold up colored cards to vote for an answer, and we're using the peer learning technique in which students will first try to answer the question, then discuss the answer with a neighbor, and then vote again on what they think is the right answer, so that the students are actually helping each other learn. As well in the Spock, we can put pointers to additional resources on the web. We've curated some of these resources, and we have linked them in the most appropriate sections, again, organized by chapter and section of the textbook. And finally, the submission of homeworks to the autograders occurs through the Spock as well, through a single upload form. The assignments themselves are all available on GitHub. Instructors can be given access to the reference solutions, but if you want to grade them automatically, this is by far the easiest way because the Spocks are already connected to the autograders as a service. The instructors can change the visibility and the due dates of any of these materials, and by hiding materials, can choose not to use them at all or can change the order in which they're presented. So we actually think this is a very nice way to bring together all of these pieces, and we have a community of instructors online who's quite active who have been using it. Our larger community are instructors who are using the book and using some elements of our online materials, but not really the entire Spock. And these have access to all of the instructor solutions and question banks that I mentioned previously. We also have a smaller group consisting of the instructors who are actively using the Spock in their classroom. This group is led by Professor Sam Joseph, who I mentioned earlier, and they actually have bi-weekly Google Hangouts in which instructors share best practices, discuss ideas or problems they're having with the course. So it's quite a vibrant community, and we would like to see it grow further. The student experience is actually smoother than it's ever been. Cloud9 is an online web-hosted development environment that is competitive with ones that would be installed locally, and we provided a setup script that runs in about 5 minutes and will configure a new Cloud9 instance to use all of the tools, libraries, correct versions of everything required by the course. So a student or an instructor or teaching assistant can literally be up and running in about 5 minutes with the new course material without installing anything on their own computers. A quick tour of the programming assignments we've created includes an introduction to Ruby, since most of our students have not used it before this course, but they have very little trouble picking it up. The Oracle of Bacon, an assignment that gives them some experience using a service-oriented architecture, making use of an external service. An introduction to the mechanics of using GitHub and deploying their code onto the Heroku public cloud. A game of Hangman that integrates the concepts of a service-oriented architecture and REST with a real deployment, and it uses a much simpler framework than Rails called Sinatra to give a gentler introduction to putting some of these concepts into practice. That's followed by an introductory Rails assignment in which students have to add functionality to an existing Rails application and deploy it on the cloud. A BDD assignment in which students create user stories and integration tests for an existing application. One complete cycle through the BDD-TDD cycle in which students have to design a new feature, write the user stories, develop the code using TDD, and then finally deploy their code to the cloud, and we'll run our cloud-based autograder against it. A legacy code assignment, which usually takes 2 weeks, in which students have to understand a 30,000 line of code application written in Rails, Ruby and Rails, and add new functionality to it, including user stories, Cucumber features, and tests for that functionality, and a deployed working version on the cloud. And finally, an assignment in which students improve the performance of the database behind a SaaS application by adding indices and judicious uses of caching. The effect of using the Spock has been fairly dramatic at Berkeley, and it's safe to say that we probably are not going back to the old way of doing things. I'm showing 2 lines on the graph here. The green line is the enrollment in this course starting from 2009, which is just before we launched the reinvented version, and continuing up until spring of 2015, which is the most recent offering. You can see that the number of students in the course has gone from a low of 45 and an historical average of 55 to 240 in the last 2 offerings. And that's only because we didn't want to admit more. There would have been more demand. But we've been able to essentially almost quadruple the enrollment in the course while maintaining a high-quality experience for the students, at least as measured by their own feedback. The red line is the students' evaluation on a scale from 1 to 7 of how useful, worthwhile, and well-organized they found the course to be. And consistently, since we introduced the idea of having the Spock materials accompany the campus course, that number has stayed consistently above 6, which is a very good place for an instructor to be at Berkeley. So we think it's exciting that we've been able to increase the number of students that we serve, which is quite important given the explosion of demand for computing education right now, while at the same time preserving a high-quality experience and garnering not only the students' praise, but the praise from the employers who are now hiring these students and finding them better prepared. At the moment, we have at least a dozen, probably more, Spocks in the US, Europe, and Asia. We're certainly looking for more, and I'll tell you shortly, if you're interested, how to sign up for one. And edX is now adding new functionality to their platform to make it easier for any one of the MOOCs that they offer to become a Spock. So we feel that this model has achieved some real traction and shows potential to be the way that curricular technology transfer is done. Now, of course, 10-minute videos in a MOOC plus automated programming assignments can't possibly have the necessary depth to really explain some of these concepts, even if the students are learning by doing. So really, it's the combination of a book which gives some depth, additional examples, another way of explaining some of the same concepts, and so on, combined with the Spock, that we think is the interesting technology transfer opportunity. In this case, one of the reasons that I made this trip is because the book just became available in Portuguese. The translators, Daniel Cordeiro and Fabio Kahn at the University of Sao Paulo, have done a magnificent job. And as with the US edition, the book connects the topics according to their Agile roles. And because it was developed alongside the Spock, or the MOOC, I should say, there's actually a correspondence between the content in the book and the materials available in the online course. One book chapter can be covered aggressively in about 1 week of class. One section within a chapter corresponds to one module in the MOOC. In other words, one set of videos, self-check questions, exercises, activities, and so on. The ebook contains links to code examples online, so students can immediately copy and paste and start experimenting with the code examples on their own. Each time we've revised the book, or each time we revised the MOOC and the Berkeley course, we've also revised the book. We're now in the first edition, and if you purchase the Amazon version of the book, which is only $9.99 in US dollars, a comparable amount in local currencies, that comes with free updates for life. And we've delivered a series of major and minor updates, both to improve the text and to make sure that the examples in the book stay up to date as the tools evolve. It's got very good ratings on Amazon. We're hoping that it will be equally successful here in Brazil, and in a moment I'll tell you how to inquire about using these materials in your classroom with the full support of the online course. We're definitely looking for more instructors, not only to use the book, but to use the Spock. We really believe that the combination of the two is very compelling. The instructor can decide which materials they want to use. They can take advantage of auto-grading. They can take advantage of video lectures if they wish. They can reorder, change due dates. So if you visit this website, you can request instructor copies of the book. There's an instructors-only discussion group that grants access to banks of questions for problem sets and exams, including solutions for the instructor. So in addition to the programming assignments, we have open-ended exam questions with annotated solutions that you could use as the basis of exams if you wished. You can read about our experience developing the course, and in particular how that experience influenced the ACM IEEE curriculum revision. And there's instructions on how to sign up for a free account on Cloud9, a web-based development environment, and get a virtual machine image immediately pre-populated that will allow students or instructors to start the coursework right away. And of course, you can sign up for a Spock. At the moment, it's free. We're hoping to keep it that way. And you'll get some guidance on a hosted course that is set up for you that you can use as the basis of all or part of your classroom activities. So, to summarize, fortunately, software as a service and the adoption of Agile have actually, in our opinion, not only revolutionized the software industry, but the way that we teach software as well. We found that it's more pleasant, easier, and more effective to teach these techniques to students in the classroom because multiple iterations really force them to get a sense of the value of the techniques, and because with the tools, the world-class tools that we can use today, they're not just listening to methodologies, they're actually putting them into immediate practice. So faculty enjoy teaching the course, students find it more relevant as reported by their ratings, and industry has given us anecdotal feedback that in some sense we're finally teaching the right things. And excitingly for us is the ability to readily allow other instructors to take advantage of what we've done and replicate our success. Textbooks have existed forever as a way of transferring course materials, but we believe the combination of a textbook, especially when that textbook is delivered in electronic format that is automatically updated, with a set of online materials that includes lecture videos, automatically graded homework assignments, and a host of other materials that are linked structurally one-to-one with the book, we believe this is the way that curricular technology transfer can happen in the 21st century. It's a great time to be creating software. The tools are better than ever, and with MOOC technology, we have the ability to let other instructors adopt these techniques with much lower friction than they had even a few years ago. And as instructors, that gets us really excited. Lastly, as an incentive, I suppose, to consider adopting this, I'd like to offer all of you a 30% discount on the print edition of the book. It's purchased separately from the Kindle edition, but if you follow the link on this webpage, you can even use your camera to take a photo of the QR code to go there. And during the checkout step, enter the 8-digit code, I guess, that you see on the screen. And for the next week or two, I'll leave it open, and you can get 30% off, because we would really like to see adoption here in Brazil. Brazilian Portuguese was one of the most important translations that we were pursuing because there's such a vibrant market here. So I hope to hear from many of you. I hope that we are able to be successful here, and I thank Danielle and Fabio for the amazing job that they have done translating it. And of course, I thank all of you for your attention. Thank you very much.